linear regression. So what is linear regression? Linear regression is a machine learning method or a model that finds the linear relationship between the dependent variable and one or more independent variables. So first of all, we should know what is the dependent variable and what is independent variable. So if you want to predict price of the houses, for example, you want to buy a house in a particular area and you want to know the price. So the price is an independent variable. Price is a dependent variable, and the place where you're going to purchase is an independent variable because it is not depending on any other variables. And the size of the house. So these are the parameters. For example, the location of the house, the size of the house, or independent variables. Based on this independent variable, we will have the price of the houses. So the price is a dependent variable. One more example I'm saying. For example, if you are doing an agriculture, the output of the agriculture is the harvest. Harvest is the dependent variable, whereas the place we are doing the agriculture is independent, and the water that we are applying, okay, and all other things are independent variable. Based on this independent variable only, you will have the harvest. So these are some of the examples. When you come across examples like this, and if you want to predict, and if you want to create a model, then you can go for this linear regressions. You can have an idea about linear regressions now and where we can use that. So that's the main important one. There is lots of algorithms. We need to find where we have to use that algorithms. The aim of this linear regression is you have to find a linear relationship between the variables. For example, if you see here, this is a graph, two-dimensional graph. Like I said, simple linear regression is one independent variable and one dependent variable. And if you go for multiple linear regressions, then you have multiple independent variables. You can see here now, x is an independent variable and y is a dependent variable. Okay. So this independent variable may be anything. So for example, we take the same examples, the prediction of prices of the house. So this independent variable is the size of the house and the dependent variable is the price of the house. So based on the size of the house, your price will vary. So there will be a linear, the size is increased, definitely the price of the house will also increase. So based on this linear relationship between this, we can use the linear regression. If the data set is non-linear, then we cannot able to use this algorithm. So wherever you have the linear relationship between the independent variables and dependent variables, we can use this algorithm. Okay, so this is the plot of this. Then you have this data point. These are the data points. Okay, if you plot the independent variable and dependent variable, you have data points like this. Maybe any data set. Okay, we are going to see everything. And what this linear regression will do is it will have a plot. So based on the model will find, the algorithm will find a linear line. This is called prediction line. So based on this prediction line only, your model will predict the value for new input. Okay, so actually we are going into the linear regression will do a prediction like this. You can see this horizontal line. Okay, so this is the prediction. So I can see that in the mathematical equations, y equal to b naught plus b1 x1. So that's nothing but a linear line between two variables. Okay, so b naught is the point where it is interacting with the dependent variable. So if we extra plot this line, okay, this is by slope coefficient, and x1 is nothing but independent variables from the data set, and dependent variable is nothing but the output of the data set. You can see here, anyway, any algorithm in the AI is not 100% perfect. It is a prediction only. How much prediction? 90% or 95% or close to 100% will be happy. So this line here is not matching with all the points, but we need to reduce. There will be some differences between the slope of the line, this line that is the linear line, with the data points, that is the actual data points from our data set. So this difference is calculated as epsilon, and if you sum all this error, we call that as mean square error. So there will be some error. If any algorithm, if you want to apply linear regression in the data set, there will be some error between the actual value as well as the predicted value. So that is called cost function. So mean square is nothing but difference between the actual output in the data set with the predicted value. So that will be given by cost function. If the error is small, then the prediction will be good. If the error is large, the prediction is not good. So that is the output from this algorithm. And if you, for example, you want to reduce that error, we have some technique. Okay, if I want to reduce this error, because this line may be this point, or you can have the line over this area. Okay, so I will show in the picture. You can see in this picture, this is a GIF file. This is the line. You can have the line over this point or any other slope. Okay, but find out the line that is closer to our data point. Once you find that line that is closer to a data point, that means the error is reduced to the minimum value. Then you can see here the error is reduced to the minimum point. Okay, initially it is larger, and then when the slope getting closer to the data points, the error is reduced. You can see from this area also the error is reducing when the line becomes closer to the data point. So how we are going to achieve it is with the help of gradient descent. Okay, so all these are information. We are not to see everything what happening through the mathematical steps, because when you apply the algorithm, that's the beauty of Python. If you apply the algorithm into it, everything will be calculated. So what is happening inside the algorithm only I am explaining. Okay. So this is all about simple linear regression. In simple linear regression, one variable and one variable, and you will have one linear line. So that is nothing but the prediction line. We call that as prediction line. So all these are based on the data points. For example, if you take the multiple linear regression, that means I'm going to calculate the price based on the size as well as place and number of floors. There will be a different number of floors. Ground floor there will be one price, first floor there will be one price, and 10th floor there will be some other price. So based on the location in the floor, also the price will vary, isn't it? So if you take other parameters, more independent variable, then your price will vary according to that. So for that, what you have to do, we have to include more parameters, more independent variables. For example, size, location, the number of floors, which floor it is. So if you include all those things, and if you calculate the price, you will get more accurate value. So that's why we are going for from simple linear regression to multiple linear regression. So for multiple linear regression, we need more independent variables. So two-dimensional graph won't work. That's why we are going for this pictorial representations. Okay, so it is a multi-dimensional plane. So this blue color plane is called the linear plane. That is the predicted one from the data set. The dots are called data points from the data set. Okay, so with that introduction, we will discuss the linear regression with the help of data set and with the help of coding. Okay, so you will get your code very soon. So before that, Colab sheets like that, I will explain how to open the Google Colab. So just go to the browser and then Google Colab. If you know, you can do. So for others, I'm explaining. Uh, collab dot Google Colab. So click that. Okay. So new notebook. Go to the new notebook. Note this procedure. Once you got the file, just open it. And then you can name the file whatever you want. So this is your new file. So in that, for example, we are going to learn simple linear regression. And you can see here, there will be some code section as well as some text section. So what is this Google Colab file IPYMD means? Interactive Python notebook. So usually you have a lot of other uh, ID also like Jupyter, PyCharm. So there are different IDs for Python. You can execute the code in that ID also. So why I'm choosing this Google Colab is it's very simple to use. You don't need to add libraries externally. So everything you can connect with the server directly using this Google Colab. So you have file, you can have this open and upload notebook. So you can download it with the .py as well as IPNB, YNB file. You can save everything you can save in the drive. So, and you can insert the code cell as well as the text cell, and you can run all those things. Okay. If you want to upload the document or files into it, you will have one folder here. So click that folder, and you have some sample data. Upload the data set or whatever you want the code. If you want to open here, just you can open. So you have any other code also, you just open using this way. So you can upload into the Google File. And if you want to create a code sheet, just click code. You can start typing the code, import pandas as the PD like that. So you can execute just, you can see pandas is a library. When just you can import it, then it is connected with the pandas. So just easy. Okay. You can execute here also. If you want to note something about this, what is pandas, you can have a notes over here and you can keep it. Pandas is a library function to handle tables. Means Excel sheet. If you want to handle means definitely you need pandas library. So just enter, it will be saved as a data, saved as a document. So that's how simple is that. We will move on to the code part. So this is the little introduction about Google Colab. I'm just closing it. Now I was given you some files, right? So I will tell you how to upload that. Similarly, Google Colab, simple linear regression. So the speed is based on your system as well as internet speed. New notebook. So what we are going to do in this session is we are going to predict the salary. Okay, so that is our code sheet. Just upload it. Go to files at the left corner and then upload. Go to salary data set. Okay, it's a CSV file, comma separated value file. If you just click it, you will have the descriptions of that. You can view the file. So what is there? There is two columns. Since it is a linear regression, simple linear regression, we need one independent variable and one dependent variable. And the independent variable is the years of experience. So these are the years of experience, and this is the salary. How many entries are there? 30 entries are there. Okay, so what is the aim of a data science engineer? So we are working in we are doing some projects, or we are need to do some project. What is the project is? What is analysis is? We need to find. We need predict the salary of a person based on it, to predict the salary of a person based on their experience for a company or any place. Okay, so for that there is some data. So any algorithm needs some data. So based on this data only, your AI, the data will gather in that company in the for the last 10 years or the last 5 years, there will be the years of experience and salary data will be there, database will be there. Based on this database, we are going to predict the salary for the upcoming employee. Okay, so that is the aim. So we have the data set, the history of the company. Based on this, we are going to create a model. That model will give the salary for, predict the salary for all the upcoming employees. So first step is here. So here are the steps. So these are the steps that is common for all the machine learning algorithms. First we need to import the libraries. Then we go class it, and we need to split the training set as well as testers. I will tell you what is the reason for that. And training the simple. We are going to train the model. Train means the AI algorithm learns the data set. Learning is training. So once the algorithm learns, then you call that as trained model. After that, based on that information, based on that knowledge, it will predict the new values. Okay. We'll start with libraries. So just click the code part. So what are the libraries we need to do for this machine learning algorithms? Three common libraries that we have to have a copy file side by side. So one is import NumPy as NP, import matplotlib, and pandas. These library functions are available in almost all the machine learning algorithms when you are dealing with data set. So NumPy is basically for array handling. So you want to do some array operations, we need NumPy. Matplotlib is for plotting the graphs. We want to visualize the data set in the form of graph. We can use this matplotlib library. Pandas is to handle the table. For example, here is an Excel sheet. If you want to analyze this Excel sheet, for example, if you want to take out the row, take out the column, okay, then we can go for this pandas. So pandas is for handling the table, and matplotlib is for graph, and NumPy is for array. So make a note of it. And NumPy as NP. So I'm just making it abbreviation. So NumPy for NP and matplotlib for PLT, and PD representing pandas. And the next step is importing the data set. The next step, we need to import the data set. So for that, so you just go to the coding part. Okay. You can see here. Data set equal to PD dot read CSV. So PD is nothing but pandas. Read is reading the document. So what is the document? What is the data set? It is our salary data. So the name should be same. Okay, .csv. This is the type of the file. So after doing this, just click the run. I'm just zooming out that you can see. Okay, so now the pandas can work on this CSV file. After that, I'm including two more commands. So what that it means? So I take x as ilog. So you need to learn what is ilog. It is a Python function. When you use ilog, you can separate the columns in your data set. So here you have two columns. One is salary and another one is years of experience. So here you don't need much information in it. So anyway, you have to learn what is this. So the first column represents the number of rows. So when you're not mentioning anything If you are mentioning only colon, that means all the rows in the data set will be taken. Okay. So this is your salary. So all the rows. So these are the rows. All the rows in a column is taken. So that is this. Where if you mention only column, that means all the rows in the column. And you have to mention what is that column. So for that we need the second part of this. Here the column is represented as colon -1. Okay. So -1 is the last. When you have -1, that means it represents the last column. Okay. So when you put colon -1, that means except last column, every column has been included in the X. Are you able to understand this? And so this is row and this is column information, which column you want. So if you have multiple data set, next data set, I will tell you that. And we go to the column now for the Y. So we are separating this dependent variable as well as independent variable in X and Y. And then we are going to plot, because that's the idea. And here also you have all the rows will be needed. And here you can see only -1. It's not that colon -1, it is only -1. That means only the last column is there in the Y. All the remaining columns are in the X. Here, since we have only one column, so years of experience is in the X and salary is in the Y. You know what is X? X is the years of experience. That means it is the independent variable, and salary is the dependent variable. Your salary is based on the years of experience. So then you can run. If you got the tick mark, then your code is correct. Otherwise, there will be some error. You can able to rectify. Next, we go for splitting the data set into training set and this. So now we go for this part of the code. I'll explain what is that code. I'm not typing. Actually, we are splitting the data set into two. Why we need to set? Why need to split? The reason is some part of data we are going to use for training, and some part we are going to use for testing. Because training is the model learns the data set. So, for example, here we have 50 entries. 1,000 entries there means 800 entries are some part of maximum will go for training. 800 entries. The remaining 200 of 1,000 remaining 200 will be there. No, use that. We are using that to test the model, whether the model is working properly or not. We can be able to test with the same data set also. Okay, so that is the point over there. So for that, there is some function called train test split from the sklearn. So remember, sklearn, you can put it in the Google sklearn. So this is the library functions. If you want any library functions, you can just go through this and you can take the code from here. Okay, library function from here. So this is the important library functions for machine learning algorithms. Okay. So we are taking from there, from sklearn model selection, import train test split. So this is the format. You can use this code for any machine learning algorithm that we are going to use. Okay. And then the function is train split. So this is X. X is nothing but your independent variable. Y is your dependent variable. So we are going to split that. The test size, we are giving the test size. What is the test size? It's 1/3 I'm giving, or you can give 0.2 or 0.5, 50/50. So usually 80% we'll use for training and 20% we'll use for test. So since I'm mentioning the test size as 0.2, the remaining 80% will be used for the random state here, 0. In your coding, see, this is for learning purpose. So if you use random state 0 in your coding also, the result, we both will get the same result, because the splitting will be common for me as well as for you. If you change this random state to 1, then the splitting will be different and the learning will also be different. So to get the same result, the same random state. Okay, so that means the splitting of 20% of your data set is common when you use random state 0 in all the coding. I'm just running it, and just move for the training. The simple, it's very simple one. So just go to the coding part. So this is also from the sklearn. Sklearn linear model, import linear regression. So regressor, just whatever the model. If you want linear regression, just go for linear regression. And if you want logistic regression, you can have different. So where I am getting this line, I'm getting from the sklearn. Okay. After that, I'm creating one variable called regression, and I am creating the model linear regression. Okay. So if you want to create another variable, you can create, or you can stop with regressor itself, no problem. So regressor equal to linear regression. So that is the model. And this fit function, what is the use of fit function is training. So when you apply regressor.fit, that means your linear model is trained by this data set, X train as well as Y. So that means 80% of the data set. Okay. So this is the function for that. Then run it. Now the model is created and trained with the data set. Next, we go for predicting the test set result, opening the test set. So there will be remaining set, isn't it? So training set is over. Now we do the same thing for test set. Okay. You can see this is the output Y predict, and this is the model name that we have created. Dot predict means we are going to predict the values for X test. So I said 20% I have taken for testing the algorithm, testing the model. So this is the model name regressor, and I'm going to test this model with the help of the remaining values. So remaining 20 values will be there. So I'm going to test that with the model, and you can now testing. Now we can see we have created a lot of things, isn't it? So just we can see, if you want to see what is happening inside the algorithm, just give X. That means print X. You can give just like X or print X, anything is fine. Okay. When you give X, what is that X? What is that means? It gives the array. So your data set has been converted into arrays. So you can see that 1.1, 1.3, all those is the years of experience. Okay, so how it is been converted into arrays with the help of dot values. By dot values, it is converted into arrays. Similarly, you can see here, if you want to see the test train, and if you want to see that, just train. So you can see the values, array values of the train. So what are the values it is taken for training, and what are the values it is taken for test? Okay. So these are the things. Now next we go for visualizing the trainings. How we are going to visualize? So we're going to see the graph. It's a scatter graph. So that's what SKTR is mentioning. Okay, so where this function PLT is nothing but matplotlib library, and then X train, Y train is the, we are going to put a graph between training set, isn't it? So that's the training set result, and the color of the dot will be red, and the regression, that is the predicted line, X train, is blue color. And these are the titles, X label and Y label. PLT show will show the graph. Now we can see the graph, amazing graph. So years of experience, it is taking the scale from 0 to 10 years of experience, and the salary is also there based on the data set. It is already taking. And this red dot is nothing but the data points in the data set. So that's what I told. So when you are intuition class, in the introduction class, I've explained the data points. So these are the data. And the model that we are creating, best line it is taken. So based on the gradient descent, it chooses the minimum mean square error predicted line. So based on this line only, your future data will be calculated. So this is our model. So just by using the algorithm, we have created the model. So that is the beauty of Python and AI. So there is lots of mathematical operations behind it, but only with the help of coding part, library functions, using library functions, we are doing this. Similarly, for the test data set also, we can see the results. So that is there in your, you will see it, just copy and paste it, same part of the code. But we are doing for train, we are going for test. The model is same. The model is same because we have created only model for training the training data set only. We are creating the model. The model is same. The first line only differ. So we can see the model graph for the test also. It's fine. Now, so these are fine. Created and it's working almost fine. Now we need to find the prices. So for example, one person coming to our company and he wants to, you want to fix the salary based on this model because already we have created the model. So how we are going to do that? So you can have this function, just print prediction by the model. So here the model name is regression. So I'm just giving regression dot predict. So for example, the years of experience is 5 years of experience. And person is coming with 5 years of experience. So I am giving 2 square brackets. That means two dimensional array. So your predict function will take only 2-dimensional array. So your model says for 5 years of experience, the salaries will be 73,345. So based on that company criteria on the database, it is predicting the salary. Okay. Is that clear for you? So this is how you can be able to create a model, simple linear regression model using the data.